know if this is necessarily going to win any cinematography awards.
No pressure, no pressure.
Go ahead.
All right, so hey, first things first. Number one, format. What is this going to look like tomorrow? Get here as soon as you possibly can tomorrow, okay? Don't kind of dilly-dally. We're in the third period of the day. You guys got band tomorrow? Is that right?
Yeah.
Like, maybe tell them, like, listen, we got to get there early, okay? I'll let you stay a little bit later if you roll in like 5 minutes late, but try to not make it happen. Way it's going to go is the first thing I'm going to give you is the calculator part, okay? So you'll have your calculator for the first half of the test. You know, it's like a one-page front and back, or, you know, 2 staple pages, one side. You'll go through that. Once you're done with that, you'll let me know. I'll give you the second part, upon which time you put your calculator away. Make sense? Then you finish off the rest of it. If it's, you know, if you're working on the calculator part, and all of a sudden, you know, 20, 25 minutes have gone by, I'm going to tell you to put your calculator away, give you the second part. You can always go back to the calculator part without your calculator. Does that make sense? You got like 20 minutes or so with your calculator for the first part, and then you lose it, okay? So, more often than not, you're going to need to know how to do these without a calculator. That's the most important thing. So, what do you want to talk about? There were some tricky ones on here. Also, I don't know if you noticed, hopefully you did, I put a review sheet. It was one that Ms. Boyle had made last year, so I kind of went through it, and it looked like it was at least decent, so I uploaded that also. So you had answers to those things as well. So let me know how you want to spend the next 70 minutes. Yeah? Number 6. Set. Yeah, sure. So I don't know what's going to be better for that. You gotta tell me. It's better to have it up here or on the whiteboard or what?
I'll follow you. I have zoomed in. This is my debut film.
Francis Ford Coppola over there. All right. Oh, you guys also already know Francis Ford Coppola is. So what do you think here? This thing's going to positive infinity. I know that I should be able to look at these different parts kind of individually. In other words, I'm going to negative infinity, sorry. If I take a look at all these different things, 3 to the x, 3 to the x again on the bottom, 3 to the negative x, etc., etc., I'm pretty much looking at 2 different options for my graph, correct? 3 to the positive x, I think, looks something like this. Agreed? I know that as x is increasing, 3 is shooting up exponentially, but as I'm getting more and more negative, it's going to 0. The only thing that changes when it's 3 to the negative x is it looks like this. Agreed? So where are all these different terms going to is the question as I'm going to negative infinity. Well, the 3 to the x in each case, those are going to 0, aren't they? The first part? Thinking. Yeah, that's going to go to 0, and that's going to go to 0. Correct? So as I continue on, I'm looking now at, all right, well, as I'm going to negative infinity with negative x, let's go into positive infinity. It looks like I'm going to negative infinity over positive infinity. Overall, what's this going to? It's got to be -1, doesn't it? They're going to the same number. In other words, think about what you would do here. The sign in front of the 3 to the exponent, that's after the exponent. Order of operations here. I take 3, I raise it to whatever this exponent is. Happens to be the same exact thing. Except the top one's negative and the bottom one's positive. Got to be equal to -1. Okay? What else on here I want to talk about? Guys, just kind of spit questions at me and we'll get as much done as we can. I'm not going to, this isn't going to be the type of class, this might be your first review session. I'm not going to stand up here and start doing these. If you don't ask the questions, they don't get answered. Yeah?
Number 13.
13. So tricky. One thing about 13 is there's 2 fractions. It doesn't happen. Good.
Excellent.
So, limit as we're approaching 1. I know the first one is going to give me 0. But 1 over 0. It's going to give me something that's undefined. I think the second one does also. I'd like to put this together as 1 fraction. I think my life will be easier. Because maybe something will cancel out if I do that. What do you want to do? How do you want to make that happen? What would a common denominator between these 2 be is a better question. Well, that, I mean, you really need to know here, what's my fraction going to be here. I think that's going to be x minus 1, x minus 2. So I think in order to get a common denominator, that's what it's going to have to be. Think that, this first one. Well, I've already got the x minus 1, so for my common denominator, x minus 1, x minus 2, 1 times the x minus 2 gets me just that, and then it also says plus 1 from over there. Put them together over a common denominator as one fraction. The good thing is, take a look at what happens. I think I end up with, well, that's really just x minus 1, which I already had down here. Limit as x approaches 1. So that's gone, and that's gone. Looks okay? Now I can go ahead and plug in my value of 1, and I get 1 over negative 1. Or negative 1 overall. Now here's one that I might have first looked at and said, okay, I get undefined, or I get something that doesn't make sense here. I get something that doesn't make sense here, so overall the thing just doesn't exist. Not the case. Look at it a little bit differently. Really, those two fractions being added together is just a graph with a vertical asymptote at 2 and a hole at 1. Agreed? This graph overall should look, well, you tell me, because this is a pretty good exercise. What should this graph look like? Because I could ask you a million questions about this. I happen to ask you the limit going to 1. I could ask you for points of discontinuity. What does the graph look like? Oh, the question answers are in student council. Indoor directing. Working hard in cinematography.
It's beautiful, man.
Yeah, sure it's not. What does this graph look like? Yeah. You want to draw a picture? No. You want to get on camera? You can. Wow, really? We're in more trouble than I thought for tomorrow. I'm serious, I'm not joking. You can't tell me what this graph looks like. It was the 1 over x minus 1 plus the other part. I put them together as one fraction. I didn't change anything. Something canceled out, and that's what I'm left with, 1 over x minus 2. I'm dead serious that if you can't tell me what this graph looks like, you've got a hell of a lot of studying to do in 24 hours. Zero. On the top, what I end up with is, well, it's just going to be the stuff underneath the radical. And then I think the x squared and what will become minus x squared should cancel out of it. Do you agree? Like I said, difference of squares here. The radical times the radical is just the radicand, the stuff underneath. So I got that quadratic. Inside outside cancels. Minus x squared should cancel with that one. And I'm left with just the 4x plus 1. Looks good? So what happens now if I'm dealing with a limit as I'm going to infinity? Not making me feel good for tomorrow. Yeah. Highest power of x in the denominator, which happens to be either the square root of x squared or the absolute value of x. Okay. If I do all of that, I'm just going to kind of extend this. Divide by x squared. Both of these are going to go to 0, so I almost don't even want to write that. But over here, that has to go to the absolute value of x. Something that in this case I could have neglected. Why?
It's going positive.
Yeah, going the other way though, I would be in a world of trouble if I screwed that up. Okay? On the top here, I'm actually just going to rewrite this. I'm just going to call it 4x, absolute value of x, and then plus the 1, absolute value of x. As I'm going to positive infinity now, what goes to 0? Anything that's bottom heavy? So that should be, get rid of that, That doesn't really go to nothing. This right here, that goes to nothing, and it's gone. Looks good? As we go into positive infinity, again, all of those go to 0. What's the stuff that's left over? Well, the top is going to be 4, isn't it? So the top of this, I'm going to call it 4. What's in the denominator? Yeah, which we sometimes screw up, and 1 plus 1, we just think it all cancels out and it's all left as 1. That's not the case here. I have 1 plus another 1. I have 2 down here. Let's not mess that up. Seems stupid, but 1 plus 1 is important. It doesn't all just wipe out to nothing. Okay? So I got 1 plus 1. Looks like this whole thing should be 2. Okay? Yeah.
Can we go over number 9?
Yeah, we okay here? Questions? Number 9. I look at this and I think like a composite function. I think, excuse me, I'm approaching 1 from the right, and I'm not even worried about anything else. What I'm worried about right now is 2's exponent. That's what I care about right now. What should that thing be going to? The 1 over x minus 1 as I'm approaching 1 from the right. I'm going to break it down piece by piece, because right now it's almost overwhelming, right? You look at it, you see a fraction, you've got 2 terms, you've got that weird exponent within a fraction. Don't worry about that stuff just yet. I'm going to go piece by piece. What should 1 over x minus 1 be going to as I approach 1 from the right? So I'm essentially asking just that. Here's one that we got to know. It's got to be quick also. It's going to positive infinity, isn't it? Do you agree with that? Give me a reason why. Because I know even just as we said that, people are like, okay, I'm going to take it for granted and go forward. I don't want to do that.
Because we're approaching 0 from the right, so it's getting smaller and smaller.
It's approaching, the bottom is approaching 0 from the right.
Yeah.
So it's going to be getting smaller and smaller and smaller in the denominator, which overall makes it go to infinity. We'll go graphically. What does 1 over x minus 1 look like? Yeah.
It looks like the normal, like, 1
So-
over x.
So
and
basically,
2's
think in terms of functions, 1 over x looks like that,
shifted over.
to the right one
1.
spot, correct? Just like before I had x minus 2, I shifted it over twice, shifted over 1, correct? So as I approach 1 from the right, there I am, shooting up to positive infinity. So that means that this thing right here, the exponent for 2 is going to positive infinity. So then what is that 2 term going to? Positive infinity? It's getting huge, isn't it? As fast as this one is growing, this one's growing even faster, because I'm saying 2 raised to that power. So that denominator is just growing and growing and growing while the numerator is staying at 10. Should be going to 0. Make sense? Denominator is growing huge, really quickly. So this thing, we're going to 0. All right? Isn't there one also?
Yeah, it's coming from the left.
Is it coming from the left, or I thought it was going to infinity?
No, it's coming from the left.
Yes, okay, right. So, this one, same idea. Coming from the left, what's happening here? Well, the 1 over x is now going to negative infinity. And if that's the case, what is 2 to that power if this thing is going to a negative infinity? Think about the curve. That was 2 to the x. That's going to 0, isn't it? If this is going to negative infinity overall, well, that's getting more and more negative. Which says drop it underneath, it's going to be going to 0. If that's the case, and that's going to 0, then it's going to 10 overall. 10 over 1, the other part doesn't matter. Okay? What else, what else, what else? What was asked about 7?
7?
Seven's hard, right?
7.
Unless you guys just flat out got the wrong answer, I thought it was easy. Possibility. Probably the worst feeling in math when like you think you got 100 on a test. Turns out it was all completely wrong. Oh crap. That wasn't even close.
One test is really hard.
Limit as x approaches 3 from the right of tangent inverse of that stuff. First of all, break it down bit by bit. What is 1 over x minus 3 approaching as I go to 3 from the right? It's this graph all over again, isn't it? Same thing. The only difference is instead of my asymptote being at 1, now it's at 3. Correct? So as I'm approaching 3 from the right, I'm going to positive infinity. So all of this is all going to infinity. My question is, what is tangent inverse going to as the input is going to infinity? What does tangent inverse look like? First of all, when it's the case with trig functions, don't they like just kind of oscillate as I go to infinity? Yeah, the trig functions, not the inverses. What does tangent inverse look like? We need to understand what the inverse function is in order to understand what the inverse function looks like graphically. Yeah, it's a-
They look like curves with
that's what tangent
asymptotes.
looks like.
Oh.
That or that.
Isn't the inverse like the same thing but horizontally?
I don't know. Let's see if we can rationalize it a little bit. What happens with tangent? The input is an angle and you get a ratio out as a result, correct? So tangent's something like this. I might say that, and then I've got my asymptotes, etc. And this one happens to be at 0, it kind of does that, doesn't it? And then it repeats, and it repeats, which is why tangent going to infinity just oscillates, keeps doing the same thing over and over and over again. What is the defined domain for tangent inverse? Better yet, a better question, a more accurate question. What is the defined range for tangent inverse? Because the idea behind an inverse function is the domain becomes the range becomes the domain. Does that sound familiar? And if that's the case, right now my domain is everything except this. My range is, well, I've got all these different points here. If I were strictly going to take this and rotate it on y equals x, I think I would go, that's the worst place to put it. If I were to take what I have as tangent, and I were now to rotate that on y equals x, what would I be looking at? Pretty sure it would be kind of like this. You agree? And then why isn't that the inverse function? This isn't a function, period. Agreed? It's got too many output values. So they said a long time ago, when we universally agreed upon, tangent inverse was only going to be defined in the positive first and negative fourth quadrant. Here's the graph, which is essentially what you said, going horizontally. Here's tangent inverse. It's got an asymptote here. It's got an asymptote here. And the domain is all real numbers. What's the range? Because that's what's really important here.
Negative pi over 2.
So you're saying right here, you want this to be negative pi over 2, and this to be positive pi over 2? Remember, those were the domain values for tangent. The domain becomes the range becomes the domain. Is that right? That was tangent. Here it was, negative pi over 2, positive pi over 2. Forget about all this crap. Forget about anything that was over here. We excluded that. And then we said, look, there's an inverse now. Now that I have a domain of negative pi over 2 to positive pi over 2 in a range of all real numbers, I now have a domain of all real numbers. Plug anything you want into tangent inverse, and it's going to return an angle between negative pi over 2 and positive pi over 2. If I didn't understand all that stuff about tangent, this problem's impossible. Because now I'm asking, all right, so tangent inverse, this function, going to positive infinity. What is it approaching? Pi over 2. It's not ever going to get there, but it's approaching pi over 2. Okay? Questions? Inverse function for tangent. Tricky. Doable though. I didn't tell you anything that you shouldn't have known from pre-calculus. It's been a while though. Probably haven't looked at an inverse function in a very long time, if ever. But you knew the concepts. Question? No? Another one that I want to look at is on the left. I want to talk about this trig function. A little bit more. Limit is an approaching pi from the left of the natural log of sine. Approaching pi from the left is incredibly important because if I just said approaching pi, does this exist?
No,
No.
Why?
it's oscillating.
Sine of pi is 0.
Because
The natural log.
natural log wouldn't exist.
Natural log at 0 is no good, correct? First of all, what's a natural log curve look like? Got to be able to know these right away. By the way, the calculator part, just so you know, your calculator's really not going to help you. Kind of could have guessed that.
Inverse of the exponent function,
Yeah, so what does it look like?
like I don't know how to draw
Not to
my
mention
finger.
that behind your phone, they can't see
So
the trace.
it looks like
You doing this with your finger for the camera? Because it is kind of like that.
yeah, I was gonna draw it like that, but
Academy Awards. Imagine Martin Scorsese just sticks his finger on there. So it has an asymptote at 0, correct? And it only exists on the positive side of x. Here it's 1. And there's the inverse of the exponent function. There's natural log. Okay? Here at e, it's 1. Okay. So why doesn't this thing exist at 0?
because that's where the asymptote is.
Left and right, they've got to match up, correct? Coming from the right, it goes to negative infinity. Coming from the left doesn't make any sense. It doesn't exist. So the limit at 0 is no good. It doesn't exist. This does exist, though. Give me a reason why.
From just
So what this is saying is, what is sine approaching as I'm approaching pi from the left? So I got to think about sine for a second. Sine, I know, looks something like this. Start here. That's pi, that's 2 pi. Agreed? So as I'm approaching pi from the left, what am I actually going to be approaching? Well, here I'm at 0, here I'm at 1. I'm approaching 0 from the positive side from the left, correct? I'm going to be having values that are getting smaller and smaller and smaller, closer to 0, but they're going to be positive values. So this thing, sine of x, is really approaching 0 from the right. Nope. Positive sign, I don't see it. If that's the case, what's the natural log going from 0 to the right? Should be going to negative infinity. Had I said approaching pi from the right, no good, doesn't exist. Agreed? Approaching pi from the right for sine is approaching 0 from the left, negative numbers, from values underneath it. That wouldn't make any sense because I know that can't happen right here. Okay? All right? What else? Question here?
Yeah,
More?
where did you get the 0 from the right? How do you 0 from the left?
Don't think of it in terms of left or right. Remember that 0 from the right means positive values that are getting smaller and smaller and smaller and smaller. So what are the output values? You're right. Pi from the left literally means from the left-hand side. Well, what are my values going to be? Here they're 1. Now it's decreasing. We're at 2 over 2. Less, 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 less. And it's getting closer to 0, but it's doing so from the positive side in terms of outputs. That's where 0 from the right comes in. Now take those values, start plugging them in here. 0 from the right says going down to positive infinity.
Is that pi?
That's pi, because 2 pi is over here. One complete revolution. Okay? All right, what else? Yeah.
16.
So, different set of directions here. Find the discontinuity, what kind, name it, tell me where it is, say why using limit statements, and then 3 or C, is it removable, and if so, how should we redefine things? Interesting. Where is there potential for discontinuity?
At zero?
How come? No, I'm with you, but why?
Well, because 1/0 is just.
Yeah, so the function, the top one, 1 over x squared, 0 plugged into that will make it a discontinuity. Is that an issue though?
No.
Because that's not part of that specified domain, correct? If I said, give me h of 0, you would plug it in here, and you'd get 0, correct? So 0 is okay. Ordinarily, it might not always be the case, but because of those domains, yeah, 0 is fine.
-1.
-1 is the other spot where maybe there's a jump, correct? Other than that, nothing else, right? Individually, the two functions, well, the bottom one's just a parabola, it's continuous everywhere. The top one is that same x squared, the only difference is instead of it being down and across it, it kind of does that and that. 0 is the only place where it might be discontinuous there, like we said, not an issue, so -1 is it. Okay, so I just gotta check things at -1. What do you wanna check? Check the limit at -1, see if it matches what the value at -1 is. Which is what, by the way? +1 from the bottom function, correct? H of -1 is 1. That's an important fact, we'll write that down. H of -1 is 1. And I really just need to know, is that the same as the limit coming from the left and the right? If it is, it's continuous, isn't it? If it isn't, then I think I have a jump. Limit from the left. -1 from the left. This was h of x. What is the limit as I approach this from the left? That should be the top function, shouldn't it? Plug in -1 and you get 1, don't you? Is that the same as coming from the right? Plug in -1 from the right would be these values. That's going to be getting closer and closer and closer to 1. So the limit approaching from the left is the same as the limit approaching from the right, this is h, they equal 1, which the value was. This is continuous, isn't it? There is no point of discontinuity. It's not enough for you to just look at this problem and then write continuous, next problem. That's enough right there. I would say there are no points of discontinuity, or at least just say it's a continuous function, and here's why. H of -1 is the same as the limit from the left and the limit from the right, which is 1. Okay? The limit overall is 1, and that's what the value is. That's the definition of continuity. What else? What else? Yeah. so- Yeah, I told you to exclude 20. didn't I? We can quickly discuss it just to get some ideas. I don't want you going nuts and thinking about this, okay? But if you take a look at 20, is there anything that kind of cancels out of here? Sort of. It's a little confusing. I think there should be a hole at 1. Do you agree? How do I know that? The x minus 1 factor in either kind of form of it, 1 minus x, x minus 1, cancel out of there, correct? That's where holes are created. Okay, and if that's a hole, that's a removable discontinuity at 1. I'll just have to find the limit of that. A couple of other things here. Where is there a vertical asymptote? Yeah. 5, because nothing cancels out with that one, correct? X minus 5, or in this case 5 minus x, since nothing's going to cancel out of here, well, that's going to guarantee a 0 on the bottom. What about 2?
No, just make a whole.
What happens at 2? 5, I understand, vertical asymptote. It's just gonna be a 0 in the bottom. 2 gives me a 0 on the top and the bottom, doesn't it? But it's not gonna cancel out exactly. One of them's in the absolute value. What happens in this situation?
A jump.
That's a jump at 2, is that right? Because coming from the left would be values like 1.9. Well, that's negative and that's positive. Meanwhile, values from the right, 2.1, positive and the same positive. That does this, or from your perspective, this, 1 at the top, negative 1 down here on the bottom. That's just a jump, okay? I don't like the way this function H is kind of put together. I would rather it asks you like individually what's happening, because that's the more likely scenario. You're not going to see this, which is kind of why I told you to get rid of it, okay? And then where's there a 0? 4 is a 0, right? That just makes the top 0 and then a number on the bottom. Agreed? So the bunch of stuff that's happening here. At 1, you've got a hole, which is removable. Just define 1 as whatever the limit is at 1. At 5, you've got a vertical asymptote, because that makes it 0 on the bottom, nothing cancels. At 4, that's 0 on the top with nothing canceling, which is fine. 0 is fine. And then at 2, since 1's in the absolute value, 1's out of the absolute value, that's where you're going to jump. Okay? What else? What else? Come on, this is all the time you have with me. I know you're sick of hearing me talk, but yeah. 18. Find all zeros, points of discontinuity, and then horizontal asymptotes, meaning what's happening going to plus or minus. Does anything cancel out? Nothing at all, correct? You can't factor x squared plus 3. It's a sum, it's not a difference. X minus 5, nothing's canceling here. Okay. So, what are the zeros?
Plus or minus for 3 and 5.
I disagree with that. 5, I agree with. 5, plug it in there. No, that's never going to happen. If it were minus 3, yes, plus or minus rad 3, but since it's positive, I'm not going to get that to come out to be 0 ever. Agreed? If you did actually go through the algebra, make sure you do it diligently. Minus 3, I get an imaginary number here. So plus or minus I rad 3, but that, I'm not concerned with imaginary numbers. So 5 is my only 0, correct? What else is going on with this? Points of discontinuity it asked me for specifically. Different types of discontinuity, hole, pull, skip, jump. What do I have? Any of them?
Is it a pole at -2?
Hole at -2, I agree. Why wouldn't it be any of the others? What would have to happen for it to be a hole?
Cancel out.
Can't, we already said, nothing's canceling here, right? For it to be a hole, well, skip, kind of same idea. I would need a hole that was refilled in the wrong spot. That's not happening either. Jump, I would need like 2 functions here, correct? Or at least some absolute value to say +1, -1. None of those are happening. Pull are the only options, and there's actually 2 of them, correct? There's one at -2, the other would be at 3/2 would be the other. So what do I have here? Zeros at x is 5. Looks like I have a pole at -2. -2, the other one we said was 3/2. And what should I know, or how would I show that those were pole discontinuities? I don't think there's any reason for me to think that they're both going to positive infinity or both going to negative infinity. I'm pretty sure that it should look something like that in each case, shouldn't it? In other words, if I were approaching 2 from the right and approaching 2 from the left, or rather -2, I should be going in opposite directions, shouldn't I? Okay, so there's my 2 pole discontinuities. I would show that limit from the left, limit from the right aren't the same, limit doesn't exist. What was the third question? Yeah.
When you say that they don't exist, you have to give a value what it would be at each one. I think just say that.
You're better off, if you're explaining a pole discontinuity, say that it's going to positive infinity or negative infinity. Okay. That's because that's more specific than that. That's two limits that go to a different number. I don't want to confuse the two.
Do poles always go to plus or minus infinity unless there's an absolute?
Poles will always go to plus or minus infinity. Yeah, by definition, that's a vertical asymptote. Okay? And then what was the third question? Continuity. Oh, what's happening as we go to plus or minus infinity? Well, first of all, where is this thing? Top heavy, bottom heavy, neither? It's top heavy. It's x to the third, isn't it? Top of this is x to the third, and I might actually write this out quickly. X to the third with some other stuff that really doesn't matter. My leading term at the bottom is 2x squared. So it asks me, what about going to positive infinity here? Where should I be going? I didn't bother to FOIL out the rest of it because I know the subsequent terms here, the x squared, the whatever, they don't matter. The leading term, the highest power, is what matters. So going to positive infinity,
It's going to infinity.
it should be going to positive infinity, shouldn't it? Plug in big numbers. Well, this one really doesn't matter, and that one matters much more. If I plug in a million, I get a million squared. I get a million cubed here. The 2 also really doesn't matter at all, right? You know, take a million squared and multiply it by 2. Well, cubing a million is much bigger than that. The bigger the numbers get, the more I'm going to infinity. What about going to negative infinity?
Be negative.
Because of the x to the third, I'm going to be going to negative infinity, correct? Cube negative a million, and you still have a negative number. This is going to guarantee to be positive, okay? What would happen if instead of it being x to the third, it were x squared in the numerator? I'd be going to 1/2 instead of plus or minus infinity, correct? Remember, top heavy, they go to plus or minus infinity. Bottom heavy, they go to 0, because the bottom's growing really quickly. And then when they're equal, that's when we're going to the coefficients of the two, okay? Joey.
Just feel like when we're writing out the poles, you
Yeah.
said that you want us to show like. it's
Yeah, so let's take a look at, we'll look at this one here for -2, just to quickly see what we should write. So I would say, the first thing which I did, I said the pole at x is -2. And the rationale is, the limit as I approach -2 from the left, what do I have? Of f of x. What is that limit as I approach -2 from the left? All I want to do is a sign analysis here, that's it. I know I'm going to infinity, but I just got to decide if it's positive or negative. Approaching -2 from the left, that's positive no matter what, correct? Any number I throw in there is going to be positive. So here I've got positive there. This is going to be negative. This, approaching -2 from the left, would be like -2.1. This is going to be negative. And what about here? Also negative? Do you agree? It looks like in that case, I'm going to be approaching negative infinity. What happens as I'm approaching -2 from the right? I'm pretty sure they'll almost all be the same, except for this one, if it's -1.9, right? That'll become positive now. So that's going to be going to positive infinity. That's all I would need to do to explain that, okay? Now, it also might be the case that maybe they're both going to negative infinity. They both go down like this. That's still a pole discontinuity, isn't it? That hasn't changed at all. They might be going to different places, same place, either way. As long as they're going to infinity, that's what matters, okay?
One, what if the both of them both be going positive and both be going negative?
Well, one quick example that I can think of is 1/x squared, which at 0, they both go into positive infinity. But it happens a lot when you square a thing.
So for like the third question, for when you where they want the horizontal and vertical asymptotes, how would you write that answer? Just
So in this case, there aren't.
there are.
There's no horizontal asymptotes, correct? If we're going to positive or negative infinity, or going to just that, positive or negative infinity, there's no asymptotes, okay? But if it were x squared and x squared, then the horizontal asymptotes would be 1/2, 1/2, okay?
If it's a pole going to the same place, should we say infinity?
So if you're gonna write the limit, like here, for this one, I would say the limit going to 0, you're gonna write going to positive infinity. If you were describing the fact that there's a pole discontinuity here, same idea. Say that the limit is going to positive infinity. If I give you this function, and I say, give me values for x where the limit does not exist, you tell me 0. Because a vertical asymptote, the limit really doesn't exist there. For convenience sake, we would just say that it equals positive infinity, but in reality, it doesn't exist. Okay? Good?
Can we go over the true or false?
Yeah. First one, p of x is a polynomial function, then the limit is whatever it is when you input b into p. True or false?
Sure.
First of all, what does a polynomial function look like? Could look like a whole bunch of different things, but I know it's a continuous function that either, if it's a quadratic, is a parabola. If it's a cubic, it has two bends in it. It has a minimum and a maximum, and it keeps going on. If it's a quartic, then it just kind of continues, it's probably like an M or like a W. There's no reason for a polynomial to be discontinuous. Do you agree? By definition, for it to be discontinuous, I would need a 0 in the denominator. Remember, a polynomial function, again, by definition, looks something like this. A, x to the n, the next term would be n minus 1, the next term n minus 2, etc. As many terms as you have. So since there's never going to be an x in the bottom, you're not going to have any discontinuities. All right? They should be continuous everywhere. Okay? A function can have two different horizontal asymptotes. I think we've seen this before. True or false?
I think that's going a different one, positive.
I'm thinking that if one's going to one thing in positive infinity, and it's going to a different thing at negative infinity, then yeah, absolutely. What if I had something like this? Better yet, you do it. Make one up that's going to two different values, one going to positive infinity, one going to negative infinity.
Inverse of tangent.
Sure, there's one right there. We just had that one up here, right? Tangent inverse went to positive pi over rad 2, and negative pi over 2. Here's what I'm thinking. Suppose I had f of x, and I said it was x to the third plus x squared, and down here I had 2x to the third minus x. Just made it up. What is the asymptote going to positive infinity? Oh, this is a bad example. They both cancel. No, bad example. Sorry. But there you go, right there. Perfect example is tangent inverse. One's going to have pi over 2, the other's going to negative pi over 2. So yes, we got two different horizontal asymptotes.
Like that percent.
Not like how that figures.
Sure, sure, because then one will be positive, you'll have a negative in the other, that'll work as well. Good. All right, that sounds pretty good.
Go back here.
C and D. So, there's something that we didn't talk about because it's not on the test. You want to learn about it right now or not?
Doesn't C have to do the squeeze theorem?
No. It's not original. C such that. Oh, C is a squeeze theorem. D is the one that I'm thinking of.
Oh.
Yeah, so C is based solely on the squeeze theorem. F of 1 is 0, F of 3 is 0. No, sorry, C is the other thing that I'm thinking about. Both C and D deal with intermediate value theorem. You don't want to know about it if it's not on the test tomorrow, right?
I'm interested.
We'll talk about that. The day after. Do you want me to send it to you? Here it is.
If you want, my fun fact was that I read that squeeze theorem is also called sandwich theorem and two policemen and a drunkard theorem.
I really like two policemen and a drunkard theorem.
And they're like
They both
beautiful.
kinda-
Yeah, they're guiding the they have like a squiggly function and it's like he's the drunkard and they're guiding him through the limit.
I feel like you made that one up.
I didn't. Oh, well, Wikipedia may have, but like,
Yeah, I don't necessarily trust everything. Yeah, sure.
Fun Fact Tuesday.
What else? Anything else?
15.
15. 15 is,
Kevin's really chicken coop.
Is there a reason for me to be looking anywhere other than 2 pi for this discontinuity? Sine on its own is continuous everywhere. 1 is continuous everywhere. It's a horizontal line at 1. The question really then is, do they match up at 2 pi? What does sine look like? Well, approaching 2 pi from the left, I think sine should look kind of like this. Here's pi. There's 2 pi, not inclusive. So, from 2 pi going to the right, I should be just a horizontal line at 1. Oh, here's 1. Here's 1.
I'm narrating it.
Looks okay? So, overall, first of all, is it a discontinuity? Yeah, definitely looks like it's a jump. If I needed to show that it was a jump at 2 pi, I would say that the limit approaching from the left is 0, the limit approaching from the right is 1, and they're not the same thing. Okay, so quickly summarize. Say jump at 2 pi. Limit 2 pi from the left. I hate this thing so much. I can't tell you the hatred I have for this one.
I feel it inhibit my learning.
I actually forgot that we were on camera. Like that right there. It's not even close. That's not my fault. Limit approaching 2 pi from the left of f of x should be going to 0. Approaching from the right. F of x is 1. They're not the same thing. They're going to 2 different places. Okay? What else? What else? I mean, if that's it, that's it. I'm not going to sit here and make you do problems. We got like 20 minutes or so. If you didn't know that the answers were online, maybe go back and double check, see what you need to do. Like I told you last night, you know, do as much of that sheet as you need to do. You don't have to go through the whole thing if you know where you're
How
going.
do you see that graph?
So I mean, what's going to help you for tomorrow? I think I said yesterday, it might not be a bad idea. I don't know, flashcard, something, whatever it's got to be to say, all right, here's this type of problem. Here's what I would do first to evaluate it. Might not be a bad idea. Take a look at like, know your graphs. In other words, know all the different iterations of 1 over x as a graph. You should be able to tell me what that looks like. You should be able to tell me what something like x minus 1 over x minus 1. You better know exactly what that graph looks like. If not, you're going to be in trouble. Something like that you might need to know on the non-calculator section. Okay? And by the way, what does that thing look like?
It has a vertical asymptote at -3,
-3, so
and
that would be
from the right it's going to positive infinity, from the left it's going to
1. What's the actual point that should be a hole? 1. Yeah, what is it exactly? What's the limit of this thing at 1? Sure, I agree, hole because of that and that.
1/4.
Should be 1/4, which would be the limit at 1. Agreed? So I come down here. Here's 1/4, and it continues on like that. There's my graph, okay? I shouldn't need a calculator for